those of you that have already joined us, thank you for attending the evacuation session of the FEMTC 2020 Roundtable discussions. On behalf of Thunderhead Engineering, I'm Kyle Perkuhn, and I will be moderating the discussion today. So we are going to introduce our panelists, and during that time, please feel free to submit any questions that you want to ask our panel today. The discussion will largely be driven by the questions that you have. And so with that, I will turn it over to, why don't we get started with our friends at Movement Strategies. If you want to introduce yourselves briefly, and then we'll just keep going around.
Okay, you start, Steve.
Okay, my name's Steve Gwynne. I'm a research lead at Movement Strategies, and I'm also an adjunct professor of evacuation and pedestrian dynamics at Lund. I gave a presentation earlier today, if anyone saw it.
And I'm Dr. Aoife Hunt. So I'm an associate director at Movement Strategies. I used to be a researcher, so did my PhD at the University of Greenwich with their Gallia in evacuation modelling. And then since then, I've gone to the dark side to industry, but myself and Steve are engaged in research, as well as working for those who do hundreds of evacuation projects.
Hi, my name is Kathrin Grewolls. I'm part of the reseller in Germany, Simtigo. I'm a lecturer in Bavaria at Regensburg. And yeah, I did my PhD in England about fire modeling, but I'm still interested in evacuation modeling. And yeah.
I'm Charlie Thornton with Thunderhead Engineering. I'm one of the senior developers for the Pathfinder evacuation software, so I'm a model developer. Yeah.
Yes.
And interior designer.
Yes, I am the last one in line. So my name is Enrico Ronchi, and I am associate professor at Lund University in evacuation modeling. So really on this subject. So I teach evacuation simulations to Lund University students.
All right, excellent. So I saw one question come in earlier, not yet in this session here, but I want to throw this out to the panel. The question is, are there modeling activities that in practice are being done less than they should be? And I saw during Tomas's talk just before Judith, someone was saying, praising the extent of the work that he was doing, and just, are there any particular types of work or areas of focus that we should be seeing more of in industry? And that's just an open question, so go ahead and jump at it, whoever has a comment.
So is the question, is it, I don't understand, so what kind of method that you use for industry?
Sorry, if you're...
It sounds like the question is what's being done less that should be getting done more.
I have a list of things that I see, but I'm an academic. I mean, I don't have as much experience as the consultants here in the real world, but from what I've seen, at least when I give courses to practitioners, I think there is, for instance, a need to do more analysis of uncertainties and more sensitivity analysis. So often we see deterministic studies being used, which in some instances can be okay, but sometimes, especially when you go to more complex infrastructures, it might be not sufficient. So one of the first items that I would like to see more in the industry is like a deeper assessment of uncertainty in complex projects.
Yeah, and I agree on this.
Please.
I totally agree on this, but we see a trend that this is much more included in practitioner works also. So I would say like 2 or 3 years ago, it was much more common to run 1 or 2 simulations and then that's it. And what we see with our customers is, and also with the official sites, that this is not usual or common anymore. It's there's a bigger focus of uncertainties and more runs, and especially for evacuation simulation in Germany, we have this REMEA guide for evacuation simulation. And therefore, they have a number of a minimum of 10 different runs in for any kind of proofs.
So go ahead, Steve. Go ahead.
No, I was just going to say, I think I totally agree that there's a understanding the uncertainty with the method that you've adopted, which is, the parameters that you've got and the settings that you've adopted. But even before you get to that point, I think there's in industry there's never enough there's usually insufficient justification for the tool that you've used and why you used it, and then the assumptions on which you're basing the application of that tool. So why are you using that particular tool? That has inherent assumptions in it, and then what are the if you like, the behavior, the underlying assumptions that you're making, even before you get to the variability and the uncertainty in the results that you produce. Because that's almost like the 100-pound gorilla in the room, right? Which is, what are you actually modeling, and how confident are you that that's representative of the things that you care about that feed through into the numbers? We almost get to the number part too quickly sometimes. And there's certainly uncertainty in that part, but there's a world of uncertainty before it unless you justify your basic assumptions and the model that you're selecting, the general approach. And it follows on from what I was discussing earlier a little bit.
Yeah, I agree with what Steve is saying. If you approach uncertainty analysis by doing something like randomizing a speed distribution or something, saying that the person on the left is now faster than the person on the right. Well, what if we do it where the person on the right is faster than the person on the left? You're going to get the same answers, and you have to do the hard work that Steve is talking about, where you say maybe that entire section of the building is somehow unavailable. How do we deal with that situation? And I think that's difficult to cope with in a lot of situations. So yeah, I'm not sure how to guide people through that process, I suppose.
Yeah, I definitely think there's more needed in terms of we're all latching onto uncertainty, but it's a really, really important one. Certainly, looking at the different environments, doing 10 runs in a stadium environment doesn't tell you any more than 2, because it's the density of the crowd. You can change all the speed distributions, every variable, and unless you're running a new scenario, the findings won't change. And so to add an extra week's worth of simulation time to your project would be not required. But in smaller, more intricate evacuation scenarios like hospitals, many more need to be run. And I've not really seen from research yet a really good sort of breakdown of the behaviours and environments that mean this uncertainty is different.
I think that's a very important point, and it goes back to the work that I think it was Dave Purser did years ago, which was, when does an evacuation fundamentally change from a physically determined high density congestion-based event and a decision-based event? So in his approach, it was pre-evacuation dominates versus congestion and flow. To it's sort of the pre-evacuation is sort of not irrelevant, but less important, and it's determined by bottlenecks and congestion and flow constraints. And I haven't seen almost like, how do you address Enrico's challenge there, which is addressing uncertainty with the scenario, but actually it's contextual, right? Because it is sensitive to the specific scenario or occupancy type or that you're looking at, or the scenario you're looking at.
Excellent. I think with that, I will go ahead and move on to, we have another question in chat. So Ian Sanderson asks, whilst there is some work being carried out in relation to the evacuation of physically disabled persons, but little or nothing to do with cognitive disabilities, given that there are an increasing number of persons with varying levels of autism, Alzheimer's, and other conditions where there can be a loss or reduction in proprioception, is there not an increasing need of research in relation to persons with cognitive disabilities? So some of this, some of you might be more aware of this topic than others. But
I can say, if I can chip in on this, I'm currently leading a project on a 3-year Swedish project on, first of all, I would say even the step before this. So often we talk about people with disabilities in a very broad way as engineers, while I approach people in the health science domain and they almost laugh at me when I start describing how these things are dealt in different regulations around the world. So the work that we are trying doing is more first starting from using categorizations of disabilities based on WHO international classification for functioning disability and health. So they have a very standardized categories used in health science, which could be a good starting point to understand how those relate then to evacuation. And I mean, when we started looking then using this classification and what research is out there, the first thing indeed that it popped up is that there is very little of cognitive disability. So it's really an important topic. And I would say one of the practical issues that we find, because now, for instance, we are conducting, really, I have a PhD student who is working on this like this month. We're conducting phone interviews with different types of people. And generally, for ethical reasons, we have to really remove those with cognitive disabilities. We even had to define a tool for screening people together with these people in the health science domain to even say, where do we draw the line on those that we can actually interview and those that we cannot interview. So sometimes it's as researchers, you enter an area in which it's even difficult to do research for practical and also for ethical reasons. I don't know if anybody else had any experience of this kind. I mean, Steve, you have been doing research in these domains, right?
And it's the classic sort of you're almost forced to bias the sample because you have to exclude certain people. Oftentimes, the outliers in a sample, you have to exclude them for ethical concerns, right? So to some degree, you're throwing the results in a certain direction. But I mean, but even going on to the next step, there's two parts to this: is do we have a sufficient understanding of the implications of such cognitive abilities on evacuation? But then, how would we reflect that in the current generation of models? Even if we did have that in understanding, and you know, for instance, on a very sort of basic level, we would modify the delays that people might incur or the decisions that they might take. So route use or initiating movement or reliance on staff or assistance. But it's so you could represent, for instance, that impact it might have. So you wouldn't necessarily need to have significant changes in the current models, but you would need to have that research basis to modify the models to reflect the impact. But as Enrico said, the specifics of it we might not understand at this moment, but we could say, for instance, a percentage change in appropriate route choice, for instance, or initial delays or the waiting for assistance. But that really underestimates the impact of it on performance, I think.
Well, if you look at the papers of Kukligowski et al. From NIST about the World Trade Center incident, then you have to reflect, what is my simulation for? What do I have to prove at this moment? Because in such an incident where you have a lot of evacuees and only a small percentage of persons with whatever disabilities, and it's not a broad band of different parameters that you have, because people tend to help each other. So you have like more like a group of people helping each other and having then the same amount of speed, or another group not helping and trying to pass or whatever. So it's when you have small groups in larger buildings, then of course you have a big impact of those parameters, but for bigger groups in buildings, it will be not those vast parameters for a lot of groups.
Well, I think you're right, Kathrin. But I think that the balance is changing somewhat with the demographic changes in society, right? Where I think what Ian's initially referring to is like where you have facilities that specifically address mental health care issues. Well, obviously they may have staff on hand and resources on hand that cope with the needs of someone, for instance, with dementia or Alzheimer's. But if you have a mixed population in, say, a mixed residency block where there are elderly or people with different cognitive abilities, then that may fall on family members or members of the public, as Erica Filigostian identified, that to address that sort of in an informal manner, and then that has a different knock-on effect on the evacuation as a whole. So it's interesting because I think the dynamic is changing, where we might have to start looking at this more as a more significant impact on general evacuation because of the changing balance in our demographic profile.
Yeah, that's right.
We cannot hear Kyle.
Thank you. So an update from Ian here. He says, lack of proprioception is usually compensated for sight and touch, which obviously are reduced in a fire. One of my concerns is that we are told there is an ever-increasing aging population. There is definitely a need. With an undergraduate student who's online here, we carried out an evacuation of small residential for autistic young adults with very interesting and varying responses. In response to that, and kind of along with what you're saying, Steve, like just the need to kind of be changing the demographics of your modeling and everything. Any further question or comments, on Ian's question and update here?
I also, it's anecdotally, I remember talking to some people in Canada when they were doing some work on a facility where people with dementia and Alzheimer's were present, and they had to modify the fire safety provisions. So, for instance, if you had a fire exit, people with, in normal circumstances, people with certain cognitive limitations would try and open the door because they had some residual memory of that functionality. And if it was locked, it would be very distressing to them. And so in an emergency, they had to make those exits more available mentally, so they would know how to operate it, but then you just had to normally you'd actually have to hide those doors against normal regulatory provisions because they would try and open it. And so there's a whole layer of complexity into the relationship between normal operations and emergency operations that cognitive issues bring.
If I can add something on this, I also have to say that I have seen a couple of years ago, I was in a conference on this topic on emergency and disabilities in Italy, arranged by the Italian Fire Service, and I've seen that there are efforts even in training the fire services to cope with those type of populations. So it's not just a matter that let's say of the building managers, of the managers of a given a facility, can be a care facility and so on, but it's more in the wide perspective of fire safety. It's important that also those that are in the fire service are trained and know how to deal with different type of disabilities, especially cognitive disabilities. I think this is an important aspect. How to put this into a model? Well, good question. there are tools that nowadays allow us to have assisted evacuation, that allow us to model intervention of rescue services. The thing that we should focus on maybe is to see what is the high-level impact of those variables rather than going to the specifics, because at the moment we still don't know too much about those specifics. That's at least how I see it.
Okay. I have another question here that came in prior to the session. This is a bit more of an open-ended question, so each of you can take it as you would like. The question is, in the next 5 years, what advances would you like to see in evacuation modeling?
Oh, I have a long list. Well, I can start with some things. For instance, I start with route choice. I would like to see more, let's say, even more intelligent agents dealing with route choice. So at the moment, we generally, I would say most of the models, probably 99% of the models, they start with a target destination, and the agents have what I called in my lecture the God's view. So they know everything about the building. So they know already where to pick the shortest route. So ideally, I would like to see some research and some future implementation of route choice models that are getting closer and closer to the decision-making process that occur in reality. Nowadays, many tools allow you to artificially reproduce certain types of behavior or to manually tweak those, but we're not yet at the stage in which the model will do the prediction for you based on the conditions that we have. And this applies to many other things, can apply to pre-evacuation time. We decide as users what is the distribution of pre-evacuation time. And now they start some models predicting the pre-evacuation time more and more based on the local conditions, the fire conditions or social influence and so on. So that's some of the direction that I would like to see in evacuation modeling.
Do you see, so there's the side that's the artificial agent intelligence level, but then there's also maybe assets in the model, like signage would be one. Like, do you see other things that need to be present in the model to allow for this type of limited information simulation?
I think with what we have today, the models, they are doing a reasonable job in approximating the environment, but it's simply, like any model, it's a simplified version of reality. So we started, and I mean, this is a field that exists probably from before I was born, but we started much when we were not even able to have an accurate representation of the geometry of the space, and now the models, they're actually getting closer and closer to represent the space as it is. But there is still a lot of work to do, and it's, as you said, it can be signage to improve the space. Everything that has to do with environmental conditions, and this popped up in a couple of talks before, we do a lot of simplifications when we deal with how people see smoke. I mean, there are things that we're not really putting into an evacuation model to a great extent, like ambient lighting or things like this. You can have the very same scenario, very different visibility if you have a bunch of lights on or if you don't have those. As I said, we are going in the right direction, at least that's how I see it, towards a more realistic representation of the environment and environmental cues.
Am I okay just to chip in? Or?
Yeah. If you want to comment on Enrico's top item of his long list there, go for it.
Yeah,
Hey.
I did a little bit of work on that about 20 years ago, just trying to make agents a little bit more adaptive in evacuation models, and it didn't really. I mean, I think Volker Schneider picked it up and did some work on it as well, and then Pathfinder sort of integrated it. But I think I know why it didn't really take off, and it's because if you're using an evacuation model in practice, typically you sort of prescribe what people do in scenarios and then demonstrate the impact of that, rather than trying to say, well, predicting how people might respond. So one is a much more broader, it's almost like a preliminary stage before you get into the detailed scenarios that an AHJ or a third party would want to see. However, I do think it is becoming more prevalent with things like machine learning, where you're actually learning which factors and which behaviours matter, rather than prescribing which behaviours you're going to look at. So it leads into the two things that I think I want to see going forward. I think, which is the interaction between, if you like, more traditional simulation, time-based approaches and a more external machine learning approach, where you're feeding new information into the simulated tools that you then take forward, and maybe a bigger interaction between simulation and having people controlling certain agents within that simulated environment. So you see a lot of this in a lot of the virtual reality work that's going on, where you're having people controlling agents as opposed to purely a machine-controlled environment. So it might be, instead of simulating 1,000 agents, all of whom are being controlled by a centralized intelligence, you have 900 of them controlled by that, but also 100 that are controlled by remote people controlling agents. So there's an elevated level of intelligence in there. So that sort of mixed intelligence approach, I think, is an interesting thing that I think is going to happen because of the various different types of models that are now available.
Yeah, I have a thought on that as well. I agree that having the capability to have more of a queue-driven evacuation is a great goal, because then you could have information leaking between agents. You could have exit signs causing agents to make certain choices rather than planning a route. All of those things. And the challenging part, at least from the model development world, is that many of our customers are primarily concerned with being able to control the scenario, as Steve is saying, so they can create specific what-if cases that they're discussing with their clients. And so yeah, there's kind of a push and pull between those two options. Now, the nice thing is it can generally be approached from a standpoint where, you know, you can have queue-driven behaviors and you can wire them to be in a certain way, so kind of everybody can win. And so I agree that it's a great 5-year question on how do we get more of that kind of behavior. But there is some push and pull on. It speaks directly to one of the earlier topics, which was, you know, interrogating the real assumptions behind the problem. You know, it's you know, to have people choosing not to use the main exit, to use a side door or something because they're more familiar with that based on a queuing system. You know, well, we added more doors, how come we can't build our building because our ASET times are still too high? You know, it creates an interesting conflict for a lot of people. But yeah, I think it'd be great to at least have the capability to be able to model things like that.
Can I ask a question, Rory?
Yes. So, Aoife, the question was, in the next 5 years, what advances would you like to see in evacuation modeling? And so Steve and Charlie were both kind of riffing off of what Enrico originally answered to that question.
Well, I would like to see a bit more direct probabilistic modeling, so like with Latin hypercube or with models of prognosis, so that it is not as important as now that we get exact parameters that we think are the right ones for our populations now, so that we can see a broad parameter choice or set. And especially with a model of prognosis, it would be much easier to have arguments for our officials that, like for evacuation of a stadium, it is not as important to have like all the parameters for elderly people, for younger people, or whatever in the right parameters set in our model. So for the practical use, this would be a big step forward to the future, like we see it now in automotive industry or aerospace industry, because I think in this part we are like 20 years behind.
Another change I would like to see in the next 5 years is to have those of us that are making simulators be able to talk to them and speak about them in a terminology that is closer to the way Gwynne talks about simulators in his talks, where there's organized boxes where certain things are happening, and you can say this is the piece of the model that's making this decision, and it works in this way based on sort of standard terminology. I get to kind of fit the way I explain how the simulator works based on terms that are convenient for me in many occasions. I remember 10 years ago when there was a website where you could describe how your simulator worked, and everybody had kind of varying definitions for agent-based and continuous space and all of these kinds of things. And since every simulator maker out there is using a hybrid of everything, then you just sort of make it whatever you want. And so I actually really like the idea of being able to follow some rules and talk about things in an organized way so that we can all be having the same conversation when we talk about how things work and what sort of choices we're making and how to make them better.
I think there's a very difficult and extremely unsexy piece of work that needs to be done on terminology and describing the process in a uniform way that it's very difficult to do, and it's a thankless task in one aspect, but you will be thanked further down the line because it enables an unambiguous conversation to take place between different developers, different researchers. It's just extremely time-consuming and difficult. As anyone who's ever tried to do it and failed as I did, but it's just very hard to do. But it's almost essential for the maturity of a field going forward, right? And you almost have to assume that anyone going into it will have a biased position, and that hopefully the aggregate will be more useful than any one position. I guess it's very difficult.
Steve, do you have a wish list of your own for the next 5 years? We can maybe hear your number one wish, and then I have another question from Julia after that.
Well, I think I sort of I do think, and I think Judith Rauscher mentioned it. You know, I do think there will be an elevation in terms of how sophisticated these models are, but it's where that sophistication is applied. Will it be applied to the individual agent and their interaction with their surroundings, or will it be at a more meta level where for instance, an AI or machine learning approach look down at the residual data set and say, what are the key factors that are influencing that? And then how do we represent those factors either in the scenario base or within each of the models within the simulated environment? So it's very much a bottom up or top down approach. But I do think, and I think that actually goes to what Kathrin was talking about as well, which is just a more sophisticated way of interrogating the domain at which we're representing.
Excellent. Yeah, I'm going to go ahead and move on to Julia's question here. I'll read it. Understanding that there are many factors that come into play when considering group behavior, as opposed to just all agents being individual and self-reliant entities, where would you say that both research and software capabilities are at with regards to incorporating the complexities of these relationship behaviors?
Very good question.
Very good question, yeah. And in fact, that was the one thing on my list that I really wanted to put on the list that I just, it's fundamental, right? It's absolutely fundamental. And I mean, look at where we are now. Look at the importance. Everything we're talking about in the COVID world is about individuals and groups and how important those bubbles are to the way that we move. It was always the case, right? It's just that it's now front and center. I know there's a lot of work being done in Edinburgh and various places in various research groups about the impact, Anne Templeton and so on, the various impact that group dynamics has on flow. And there was the old adage that as the crowd got bigger, so the group dynamics could be more and more discarded, you know, individual. But I've never thought that was actually accurate. And I think you can see how much it translates up. If you depend, I mean, the work that Aoife and Enrico and I did in terms of the different cultural perspectives of the crowd and the dynamic, the underlying dynamics, and the impact that might have on the flow rates that are achieved. So I think it's extremely important and fundamental to our work going forward.
And I mean, the way I understand this is that for a developer, I think it's not that difficult to implement the logic. The problem is to know what the logic should be for those group dynamics. And so I think that the developers are catching up with what is out there in terms of research. The problem that we still have some gaps in the fundamental understanding of how group dynamics work. Mostly, I have to be honest, this is very difficult work to fund because most of us are engineers, so we cannot really look at fundamental questions and get easily funding for that. But I know, and I guess many of us are aware that there are some fundamental theories that can help us interpret group dynamics. And we can think about the social influence theory, social identity theory. So there are some theoretical framework that can help us, at least qualitatively, differentiate between different scenarios in which we may have different impacts of group dynamics. But as I said, on this one, I have to say that we should not put any blame on the developers. They do their best. The problem is us, that we have hard time in finding funding for digging more into these variables. And there is a lot of interesting research that comes often from other fields that are not engineering related, non-fire engineering, like psychologists or cognitive scientists. But those, sometimes it's very hard to get them in the engineering world. That's something that I've seen in a few instances. It's very hard to get those people to even talk with engineers.
I think as well, and sorry, just quickly, there was a paper years ago in the IFSS, I think it was from Hewitt and Jones, and they were doing about the impact of leadership and groups on evacuation, and they did some work on it. So it's a long-standing known issue, right? So, and assuming that people move as individuals as opposed to groups is a massive simplification on any evacuation analysis. It's just huge, and as Enrico said, like, the models can do it, but it's a tractable problem.
So one of the my take on it is, first of all, I appreciate all of the grace I've being given by Steve and Enrico, is that when we started working in Pathfinder on people moving together as groups, getting people to move together as groups, we had done something earlier in a test project. We had 3 different implementations for having people stand close together as they move around. But when it came to having the user specify what the groups were and how that should work and how close they should stand apart from each other, the specification process took months, and we scrapped the first 2 versions, and it was extremely complex. And that was for something that, we had working in test builds in a week in the simulator. And so it's kind of an interesting problem in that you think in terms of, well, why can't the simulator just make people walk next to each other? Well, the real question is, you want to understand what you're telling the simulator to do, and you want for that to give a coherent, explanation of what's happening. And so there's actually, well, how do we specify it? What are meaningful input parameters for how groups move? Things like that. And so it's kind of an interesting problem where the real work is not necessarily where you would think that it is.
Really good question.
Excellent. Why don't we go ahead and move on to the next question? I think this may have been tangentially covered briefly, but Romain asks, how do you see artificial intelligence being used in evacuation modeling? Any thoughts on that?
It's always hard to know what somebody means when they say artificial intelligence. I mean, you could say, the computer's moving people around, or we got it taken care of. Artificial intelligence, check. I think usually when people are referring to that, they're talking to some extent about machine learning or identifying sensitive parameters by doing multiple simulations, things like that. I think those are valuable. Personally, I don't know if this is a reasonable global stance, but it's sort of my personal stance. I steer away hard from artificial intelligence solutions where I can't explain why the model is doing what it does, because I feel like, we're making tools that give you answers, but the answer is far less important than sort of the explanation for how you got there. And so I when we discuss what we're going to do with Pathfinder, I tend to favor certain kinds of applications of artificial intelligence and machine learning over others. But so I guess that's my answer, is that it really depends on what specifically you're interested in. I think there is an interesting landscape of using machine learning to bake down information from lots of simulations into sensitive parameters, things like that. And that's where I see a valuable future for it.
If I can add something on this, I mean, I totally agree with what Charlie said, especially one issue I want to highlight. I see a lot of potential in machine learning to study crowd dynamics, because we can really collect millions of trajectories and millions of data. But this doesn't apply for evacuation. We don't have so often data from actual evacuation events. And we all know, for those of you that have started looking at machine learning, the job that those algorithms do, they are as good as the database on which they're based on they are. So the larger and the better the database, the better are the algorithms. So we don't deal with the problem for which we have a lot of data to begin with. And this is a long debated issue in the evacuation community. We know that we always wish to have more data from real events, more drills, more data to work with. So before putting all my money on machine learning for evacuation modeling, I will be very cautious in first putting a lot of efforts in getting the data together to run. Different instead if we talk about crowd dynamics, because crowd dynamics is very easy. You put a camera somewhere and you record millions of trajectories. But I mean, very easy. It's easier. Let's put it in this way. But it's not the same as for evacuation simulation.
So there's, I think, one question we haven't gotten to yet, and we are just past the end time of this. We're leading into the networking and break time frame of the morning or afternoon, depending where you are. And so why don't we go ahead and quickly address Ian's other question, and then we can kind of wrap up this session. So his second question here is there not a danger of developing models with an extremely high level of sophistication, but they're not used to that level due to cost constraints imposed by developers, or imposed on developers, rather, maybe?
It's fundamental, right? It's every time you use a model, you should explain the assumptions that you're adopting when you're using that model, what you're assuming, what you're not, and what functionality you're using and what you're not. That's just responsible use of a model, right? And responsible selection of a model. And if you're not doing that, you're potentially, if it's not deliberate, you're potentially misrepresenting the level of sophistication and the behavioral model that you're employing.
Yeah, I would also say that that it's already the case in industry that models are not being used. It's already the case in industry that they're not used to the degree of sophistication that they would for. And so one thing I'd like to see, and I think this might be a very early on question before my mic dropped out, is closer work between industry and research to make sure that the models that are being developed are going to be used in the way that they're intended. Because at the moment there's a big gap in those two things. And while I have the microphone, let's not cut out again. I think it would be really good to widen the definition of evacuation. We're very focused on evacuation as a linear time. I know Steve presented some of our hospital work earlier today, which shows that actually evacuating is anything but linear. It's cyclical. And evacuation is just one type of response. And if you look at other strategies to put in place in evacuation, having this definition of pre-evacuation time and this linear modeling that we're all sort of wedded to, collecting data within that is quite limiting. And going back to Enrico's point about machine learning, there is live footage data, people's response to it. It doesn't have to be fire, it's an emergency. Evacuation is just one response. So I think there's adjacent data. Widening that definition would not only have the real life application, but it would mean that we could pull into other areas of research.
Is there time for another little response, or are we?
Yeah, please continue. Yeah.
I also think that it's not just the model, the tool, the simulation tool is only one part of the sophistication, right? You could employ no model, no simulate, no quantifying model at all, and come up with a very sophisticated analysis. I think what you want is sophistication throughout the modeling process, understanding what the key issues you need to address, the assumptions on which it's based, and then using potentially a simple tool and a complex simulation tool to gain insight. So I think you're right. You don't always need, you don't just automatically get benefits by increasing the complexity of the tool, but you can get benefits from sophistication in the process. Now, obviously, the more you do eventually want to get some of that embedded in the tool, but it doesn't automatically provide useful insights without informed use and subject matter expertise.
Excellent. I think we'll go ahead and move to any closing thoughts from the panel. So that was all the questions we had submitted, but if you have any final remarks you'd like to make about any of the questions that have come up or just anything else in general, yeah, please feel free, and then we'll move on to the networking break. Enrico, yeah?
I can just add something. I mean, a big question for us will be linked to COVID. So if this COVID or this type of pandemic are here to stay, the whole field will be on the spotlight, everybody that deals with crowd dynamics, and the whole field will have to carefully reevaluate all the assumptions that we used so far. As I said, we don't know this yet, but that's a big question mark that we have for at least the coming year, to see what will happen in that direction. If we really will go back to a pre-COVID normal, or if we will have a new normal in terms of crowd dynamics. So that's just a final thought from me.
You're absolutely right. Sorry.
No, please go ahead, Aoife.
Yeah, just to reiterate, I think what I don't know if this has been addressed while I was in a black hole, but we already know that some of the measures put into place, social distancing, is going to have an impact on evacuation. So from our work in Evacuation, for example, the impact of social distancing and other COVID-related measures, for example, in creating toilet queues for the first time, you never had to create a toilet queue, but blocking entrances and reusing in different ways to do these one-way systems and other things, and putting up screens, is already having an impact on planning. So I think this is going to be something that's going to be a part of the message planning, because it's changed the structure. But as Enrico said, repurposing our knowledge and expertise in movement analysis and crowd analysis is going to be such an important part of the solution, that we all need to be, as researchers, ready to quickly adapt. And we may at some point need to form groups and start building consensus and building ways of publishing. Or there is no journal for this. I think we need to start thinking about that as a community before the requests start coming in.
I was going to mention that I think this was a very good conversation, because it highlights something that I frequently think about with working on a simulator, which is that we have customers that have a time scale that is days. I have a real problem that I need to solve right now for my own customer. We have model developers who are operating on a time scale of ideally months, because we're sort of working on a work queue and trying to get things done. And we have researchers who are working on a time scale of years, because you're in the rhythm of getting funding for your students and things like that to do research. And we make a lot of exciting, shiny tools when we're sort of listening to customers that have problems right now, and that helps us be responsive. What really helps push us forward is the long-term lever. Like, I remember yesterday, Enrico, you were talking about the exposed model that you were doing for COVID, and everything I was thinking while you were talking about that was, we need to try this now. We've been putting together hacks to get people information for COVID, and you segued into talking about getting a student to do work to figure something out in a 2-year sort of a time frame. And it's like, no, I need to talk to Enrico and figure out how we can code up a test version of this thing today, and it's good when we all discuss and figure out where everybody's at on these things, because I think long-term progress is about vocabulary, and it's about becoming a more grown-up professional industry and developing that long-term sightline, while we keep things going. So I appreciate the conversation today.
You're so right, Charlie. You want it today. Enrico wants it. Yeah, me and Steve won it yesterday.
Kathrin, any thoughts?
And it would be great to have a nice tool to monitor crowd movement only by mobile data, not installing cameras everywhere and all this. You can now just enter, before you enter a shopping mall, you can see on Google how many people are there now. Is it crowded or not? If we could get tools, to use those mobile data that are there anyway, because everybody has at least one mobile phone with her or with him. So this would be, I think, a great step forward to get more comprehension about crowd movement.
The good news is that exists. So we have one, and lots of consultancies have similar tools, but it's all sort of purchase data. So, but I totally agree. I think we're missing a link there between the data owners and researchers, because as you say, there's an absolute wealth out there, and it's already been collected for commercial purposes. So if we can find a willing organisation and some good links, I think looking to tap into that source of really the right thing to do.
Okay, and Steve, any final thoughts from you?
No, I mean, I think it's an interesting dynamic, right? Because it's like, it always reminds me of the landing on the moon or the space shuttle. The computer in the space shuttle was a generation behind, right? So to plan to develop something, by the time you've got it in place, you're, especially at the speed things are changing now, you're automatically a generation of research out of tune. So I think I don't know how to square that circle, but I think a much closer collaboration between industry, developers and research, much like the conversation going here, is essential if we're able to catch up and meet those needs as we go forward, and have a more agile approach to applying the tools that are available.
Excellent. Any final responses to what Steve said? Okay, well, I want to thank my panel today. Thank you all for your insights and your time. And thank you to everyone who asked questions for the panel, of course, and everyone else who was able to attend. So now we're going to transition into what remains of the networking break before we get back to presentations. So feel free to use that networking tab to meet up with other people attending FEMTC. If you have follow-up discussion that you'd like to have with any of our panel, I encourage you to do that in the stage chat. If it's a conversation that the rest of the attendees might find useful. And as Eric Benson has pointed out, today we updated Hopin so that now there is the people tab of the chat panel. So if you want to continue a conversation with someone that you've networked with, you can use that as well. So again, one final thank you to everyone involved for the evacuation roundtable discussion. And I look forward to hearing more in the rest of FEMTC. So, thank you.
Thanks a lot.
Thanks.
Thank you. Goodbye.
Bye.